All right, this one's going to be kind of long, so get ready for this. This is roots. You've talked about roots before. The essential question, why would I need to use square roots or cube roots? So I came up with a problem for you. All right, so I'm redoing my bathroom right now, and I took a picture right before I left to go to Home Depot, and I remembered that the area was 64 square feet. Okay, so that's the total area of the bottom here. I'm putting in some heat into the floor so that in the morning it'd be nice and warm for me. But I forgot to measure the side lengths. Dope! So I want to figure out how to find the side lengths if I know the area. So I took out my little paper here and I figured out, okay, well, I know a square is equal on all sides. And I know the area is 64 square feet. I knew that before I left. I wrote that down, but I forgot the rest. So I can say, well, look, a square's got equal sides. And I know that to find the area of a square, it's base times height. But in this case, the base and the height are both the same. So I could say that's side times side, which is known as side squared. So I've got everything I need. Now I just got to kind of figure out the math. So since side squared and the area is 64, I can say that these are basically the same thing. So I set it up. S squared is 64. So what times itself is going to give me 64? Well, I want to undo the squared value. I want to undo this on both sides. Whatever you do to one, you got to do it to the other. So I have to use square rooting. That's a little symbol that you see on your calculator, square root. So I square root both sides and I find out that 8 times 8 gives me 64. So great. If I know that the area is 64 square feet, then each side is 8 feet. So this is a good opportunity to talk about what square roots are. A square root of a number is one of its two equal factors. So what are the two numbers that multiply each other to give you the number? So that's a square root. Okay? A perfect square is when the square root happens to be an integer. Okay, what do I mean by that? Well, let's figure some of these out. So the square root of 3, okay, we use that with our calculators. We can go 3, we hit the little square root symbol, and it gives you this 1.732, yada, yada, yada. So basically, if I multiply those two numbers together, times it by 1.73, it's going to get me really close to 3, right? If I was able to do it perfectly, it would work out to 3. If I go square root of 4, so I do square root of 4, 2 times 2 gives me 4. So that happens to be a nice 2. That's an integer. We call those perfect squares. Oh, it's so perfect. I don't have to write all these numbers. So perfect. If I go one more, square root of 5, not so perfect. That would be the square root of that, approximately. But those are not considered perfect square. Only this one here. And we might as well talk about the radical sign. So the radical sign is, see this on our calculator, it's called the radical sign. That's used to indicate a square root. So radical means square root. That's indicating a square root. Okay, so take a moment to realize it's really important for you to memorize these perfect squares, okay? Because they're going to be helpful later on in high school and later on this year. It's going to help your life. So write them down if you need to. If you already know some, then don't write those down. But square root of 1, square root of 4, square root of 9, all the way up to 225. And I will tell you, most students know all the way to 10. They can do that, no problem. It's these ones over here that sometimes give students some problems. They don't come directly straight to your mind. So try to memorize those. We'll quiz you on that stuff some other time, but just memorize those. Let's go and get some practice in. Okay, practice with the numbers. Square roots. Start with this first one. Actually, I'll show all of them here to you. Let's go. Square root of 64. What two numbers times each other give you 64? If you remember from the example, 8 times 8 is, so I just write it one time. That's a perfect square. 121, if you wrote down your ones I had you memorize, we should know that's 11. 11 times 11 gives you 121. Now this one, what the heck is this symbol we see here? That's called plus or minus. So when you see that, pretty simple. We know the square root of 9 is 3, and all I have to do is put plus or minus. We'll talk about that more later. This next one, again, plus or minus, and square root of 16 is 4. Why do I put plus or minus? Well, now I'm going to come back to it. If I go negative 3 times negative 3, I get 9. If I do 3 times 3, I also get 9. So it could be positives or negatives in this case. Same thing over here. Negative 4, it gives me 16. And positive 4 times positive 4 gives me 16. Okay, so in some instances, and we'll talk about it in a minute, you'll need to know that it's plus and minus. How about over here? What do I just have a negative? Well, the opposite of the square root of 100. Well, square root of 100 is 10. The opposite of that would be negative 10. How about the opposite of square root of 25? That'd be negative 5. How about this next one? Okay, problem. Big problem. Wait a minute. Negative 4. The only numbers that multiply to give you negative 4 would be negative 2 and positive 2, but they're not the same. So unfortunately, there is no solution. You can write it like that. It's like a 0 with a slash through it. No solution. Same problem over here. Look, I can't find two numbers that multiply each other to give you negative 64. They're not the same, so I would say that there's no solution to that. Now it's time to do an example when you will use plus or minus. So if you're setting up the problem yourself, you're trying to do the math yourself, and you realize, look, I've got x squared. I know it equals 121. So in order to get rid of this squared, you're going to square root it. Those are opposites of one another. And I square root the other side. So now my answer is going to be x. And over here, what you want to do is you want to be able to tell me that it's both plus and minus 11. Either one of those answers will give you the correct work. So it's like, hey, you got to remember that. So when you're the one adding the square root symbol to both sides and solving a problem, which you'll do more of later, you have to remember that you have to include both the positive and the negative of that answer. Okay? Keep that in mind. All right, what about examples with fractions? Well, no problem. Look, the square root of 25 over 16. This is the same thing as me saying the square root of 25 over the square root of 16. And both of these happen to be perfect squares. So this would be 5 over 4 would be my answer. Over here, I can split this up again. That's square root of 100 over the square root of 121, which is 10 over 11. So that's the only difference if you see a fraction there. All right, that'll be it for this video. There's a continuation of this when we'll talk about cube roots.